All right, so why don't we go ahead and get going? It's about a minute after the scheduled start date. I know they're pretty tight on time here. So welcome all. This is the CCDA on FHIR tutorial. My name is Rick Geimer. I'm with Lantana Consulting Group. I'm also one of the co-chairs of HL7's Structured Documents Working Group. I'm a co-editor of Consolidated CDA and the lead on the C-CDA on FHIR project. Lantana, basically, we're a health IT consulting services company. We do things like CDA implementation guide design, FHIR profiling, program management, stuff like that. So during today's tutorial, we're going to talk a little bit, give some background on CDA and consolidated CDA. And just to show of hands, how many people have worked with CDA before or CCDA? About a third of you, okay, maybe a quarter. So that's useful just to sort of background, so you understand where CCDA on FHIR comes from. Then we'll go into the CCDA on FHIR spec itself. We'll also talk about the US core profiles, which CCDA on FHIR uses. And then we'll actually also give a live a demo and walk through the specifications and some of the other work that we've been doing in this project around CDA to FHIR transformations as well. So first of all, just some background. CDA is a HL7 version 3 based specification for representing clinical documents and defining their structure and semantics. It's an ANSI and an ISO standard. It's been around, CDA release 2 since 2005 and seen a lot of use. It was cited in US federal regulations, what are called the meaningful use regulations. So a lot of certified EHRs are required to output CDA documents. You know, it's got some problems, I would say, mainly because it's a version 3 based spec. It's kind of difficult to use. The way XML is used in HL7 version 3 isn't all that friendly. The data types are different from what everybody else is used to. So there's some issues with it, even though it's seen widespread use. And that's kind of one of the impetuses around moving to FHIR-based documents. Consolidated CDA is, again, it's a implementation of CDA. So CDA itself is a generic specification. It's can be used to define any type of document. It's international in scope. Consolidated CDA is a very US-specific implementation guide that says how we'll do certain document types like consult notes, discharge summaries, continuity of care documents, and such in the US. So this implementation guide, again, is what got cited in federal regulations, and most EHRs will export them. In particular, you find a lot of them exporting this continuity of care document, which is really a summary document describing care over a period of time. It's used often for transfer of care scenarios. So FHIR and CDA, they do have some similarities. They both support profiling for specific use cases. In CDA, we call that templating, but in FHIR, we call that profiling. But it's really the same thing. You're often basically just saying what's required, what's optional, binding to value sets, and things of that nature. Also, in both standards, human readability is the minimum level for interoperability. CDA really sort of introduced this idea of a human readable narrative block that goes along with the coded data. In fact, you don't even need coded data. You can just have human readable only documents. FHIR picked up on that and went with it as well and put that as a base level of interoperability across all resources. And you can think of it again as a patient safety issue too. Maybe you're a receiving system and you're not very sophisticated and you don't know how to process SNOMED codes and all these other things. You can always bring those resources or CDA documents or FHIR documents up on a web browser and just read the information and then continue treating your patients. Both standards also have validation tooling and profiling tooling available as well. The key differences, I would say, with FHIR are you can really use it out of the box. And when I usually put quotes around that. FHIR resources are already very detailed, much more detailed than CDA is. You've got things like allergy and tolerance resources, condition resources, goal resources. They're already very specific and have the exact fields that you need. CDA often does not have those things. We just got observations, and then you profile them or template them to meet your specific use case. So FHIR you can often pick up and use out of the box, but I would say that's useful in your own environment. Like if you're just a company that's using FHIR internally, you can do that. But if you want to use FHIR for national exchanges, I would still recommend profiling, because you need to agree on things like what vocabulary you're going to be using and such. FHIR also is not restricted to just documents. CDA is just about clinical documents. Okay, so if you want to send a message, CDA is not the standard to use. Version 3 messaging, at least in the US, never really took off. I know there are some places in Europe where it's used, but it never really took off in the US. So there's really no sort of equivalent messaging around CDA. Rather, in the US, we would often still use HL7 version 2 messaging. So FHIR, you can do both messages and documents. Just use resources as a data model. You've got a lot more options. Implementer tooling is generated with the specification in FHIR, which is great. It means it's always in sync. You've got Java APIs and .NET APIs and such. They're generated with the tooling right out of the structure definitions and such. So they always work as long as the build builds. And FHIR has a much tighter coupling to APIs. It's got the RESTful API built in. But I think most of you know that, all that stuff, since you've been here at DevDays for a while now. So when we started looking at FHIR from a document perspective, one of the first things we do is we sat down with Grant Grieve, myself and a couple of our other co-chairs in structured documents, and started looking at can FHIR handle the CDA use case? In other words, can we use FHIR for clinical documents? And if basically that was the question we were trying to ask, and if the answer was no, we would fix FHIR. Back at the time this was DSTU1, and the answer we felt was no, so we fixed FHIR. Those changes went into FHIR DSTU2, in particular the composition resource. We added a lot of more detail to that, and fleshed out how bundles are used to wrap documents and other resources. And one thing we did was we actually went through just sort of line by line in the CDA spec, and then documented where these fields of data would appear in FHIR, in particular the FHIR composition resource. So those mappings are basically in a Google Docs spreadsheet. They're still available if you want to go up and take a look at them for historical reference, but realize that this is FHIR DSTU1 stuff, so it's not going to be current and up to date. The next thing we did, after we did that and we got DSTU2 out the door, is under the auspices of what's called the Argonaut project, we started looking at how to map consolidated Cda templates into FHIR. And that again was a set of conceptual mappings that were done in Google Docs spreadsheets. They're based on a sort of pre-DSTU2 FHIR. It did, some of those mappings actually resulted in some key changes that made it out just in time for DSTU2. But that gave us a really good understanding of the coverage of the various resources that were in FHIR, and whether they could cover the same use cases that were covered in consolidated CDA. Things like problems, allergies, meds, goals, all that type of stuff. After that, and after FHIR, basically DSTU2 and eventually STU3 got out the door, we kicked off the C-CDA on FHIR project, which its goal is to go beyond conceptual mappings and actually make implementable, usable profiles. So that you can start actually creating documents that meet the C-CDA use case using FHIR. You don't need to use CDA at all. Just one more quick slide on sort of the differences between CDA templates versus FHIR resources and profiles. CDA is based on the HL7 version 3 reference information model, or RIM, and it's tightly coupled to that. Basically, the way you work in version 3 is you take the RIM, and then you refine it, you create this refined information model for your own use case, and then you can go and template that itself further. In FHIR, you don't do that. Rather, you start with your resources, and you build that, and then you can sort of do mappings back to the RIM if it's needed. Most resources have those mappings for folks who want them, but you don't need to use that for a generic model up in the sky at all. In other words, everything's very concrete from the get-go. And again, these resources are directly usable. And then you can take those and profile and localize them for your own use cases. Unfortunately, one of my tech editors got this diagram, and I did actually have the profile slightly below the templates box there to show that they're actually less abstract than CDA templates, but he fixed it for me and unlocked the graphics. So anyway, so FHIR implementation guides and profiles. I'm not going to give a tutorial on this. I think there's some other courses in here on FHIR implementation guide development. But basically, a FHIR implementation guide consists of a collection of profiles, value sets, example files, and human-readable documentation that is all sort of wrapped together in a package, and then basically produces a HTML documentation that you can browse through, click through on the FHIR site. There's an implementation guide resource that ties all this together, and basically references all the information that you've got in your IG. And then there's a FHIR implementation guide publisher that can take all this information and again build that human readable documentation that would show up on the site. But I do want to note that the FHIR IG publishing process is rather new and still quite buggy. So it's not necessarily a fun thing to do. But when it works, you get some good documentation out of it. So the C-CDA on FHIR Spec, as I mentioned, it is a FHIR implementation guide. It's a US realm one, so it is specific to the US. We use the terminologies and value sets that were cited under meaningful use and used in consolidated CDA, so things like SNOMED, RxNorm, LOINC, and such. Other countries might choose different vocabulary, but that's what we use in the US, and this implementation guide requires that. Basically, it picked up where those Argonaut mappings left off, and its goal is to create implementable FHIR profiles for the CCDA use case. So the scope was basically to represent consolidated CDA templates for clinical notes release 2.1. So that's the full name of C-CDA 2.1, basically. But represent them using FHIR profiles. The first stage for this project, which we're wrapping up, was to create document-level profiles on the composition resource and all the contained sections. And any coded data that is used by sections, we actually leveraged the work of another project called the US Core project, which went in and created FHIR profiles for the US for things like allergies, meds, problems, all the stuff that we need to represent anyway. So we just pointed at them and said, well, we're going to reuse what they did already. So if you want to find CCDA on FHIR, it basically went to ballot in January 2017. If you want to see what went to ballot, you can click on this first link, or you can go down from the FHIR homepage and click under Implementation Guides, published by HL7. You can find it there. That's not the one that you want to click on, though, because that's the old one with all the broken links that people send hundreds of negative ballot comments on, saying fix all these broken links. So what you want is the one that's in the current build. It's found here, build.phir.org/IG HL7 CCDA on FHIR. And in there, that's the current one that we just wrapped up, implementing all of the comment resolutions. And we're actually requesting for publication this week or next week, depending on when we can get some of Graham's time. So since it's unlikely this week, it'll probably be next week. So some details about what's included in the spec. We include composition profiles. We include examples for all the document types. There are extensions that are used, some that are US specific, but some that may actually make it back into the core composition resource itself. One thing we have not done yet is we don't have detailed mappings back to C-CDA in here. Rather, that's ongoing work. There are other folks that are working on the actual mappings. Basically, because like I said, for US Core, we just pointed to them and said do that work, but they hadn't always went back and mapped back to C-CDA itself. So we didn't take that upon ourselves to do it. In other words, the folks who created those profiles were hoping that they'll do it, and some of them are. We did not create profiles and resources other than composition, except in maybe one case, I think. And we also did not represent unstructured documents, which are basically in CDA. That's where you've got a CDA header with basic metadata, and then you just reference a PDF. We didn't address that because we were still discussing how we actually wanted to handle that in FHIR, whether that should just be a document reference resource pointing to a PDF, or whether we should find a way to handle it in composition itself. And that's still kind of a topic for discussion. So one of the core profiles, and I know this screenshot is unreadable, that's okay, I'm going to bring it up and actually walk through it a little bit later. But one of the core profiles is the US ROM header. So this is a profile that defines all the document metadata that is common across all the different document types in consolidated CDA. So it basically says that we're going to, for instance, use the US core patient profile for the composition subject, that we're going to use US core practitioner for the author of the document, and so on and so forth. This profile also defines all the extensions that we use in the header, things like if we want to represent who the transcriptionist is, which is not part of a core composition resource, but rather we felt it was needed for the US use case. So I mentioned the US core framework a little bit. You can find it at this URL here, and towards the end I'm going to actually walk through and demonstrate US core. But it contains FHIR profiles to address the Common Clinical Data Set, or CCDS as it's called. And it's got profiles for everything that's here, so allergies, diagnostic reports, goals, immunizations, medications, practitioners, lab results, smoking status. So all the things that in the US we've decided is part of this common clinical data set that everyone should support. Some of the key profiles that are used in the US ROM header are patient, practitioner, and organization. I'll go through those in a little bit more detail here. So the patient resource, basically it's a profile, or a patient profile. It's a profile on the patient resource itself. And typically the pattern that we've done in US Core is there's a lot of information that's available in the patient resource. What we've done is we've flagged the ones that systems in the US must support. So in other words, we said every patient must have one or more identifiers present. They must have one or more names. Their gender is required, birth date, etc. So all this information is present. We've also created extensions for some metadata information on things like race and ethnicity and birth sex that the government wants to collect for various statistics and such. So you'll see this pattern, all these red S's basically means must support. So even if something is optional in here, such as communication, their language and such, your system as a receiving system, you at least need to support it. You need to have a field where you can capture that information, even though you might not actually have it for a given patient. As Graham pointed out, even though we made certain things required like human name, there are cases where maybe someone doesn't have a name. So in some areas we've actually made things a little more required than they actually probably should have been. And some of those I think will be loosened up in the next revision of US Core. US Core Practitioner, again very similar. All we require here is just an identifier and a name for a given practitioner. Again, there's a lot more information that optionally you can add, like all their telephone numbers and such, but these are the minimum that every system is required to support. And very similar for organization. For here, we've got, again, requiring their identifiers, whether they're an active organization, their contact point for telecom and such, and their addresses. And optionally, an endpoint if you want to be able to actually interact with them using things like FHIR. Some extensions that we created are listed up here. These are fields that are present in the CDA specification, but weren't present in FHIR, and weren't deemed important enough for the core FHIR use case. In this case, data enterer is a profile in the US core practitioner that represents the transcriptionist. Informant is another profile on a practitioner that represents anyone else who provided information to the document other than the primary author and such. Information recipient is who we expect to actually receive a copy of this document, like for a referral or something. So we store that in here. And then we get a few more like participant just for any sort of generic participant that we need to record. The performer for certain service events we record as a profile on US Core Practitioner, or rather we reference that. And then for authorizations, things like consents and such, we point to the contract resource. So for the document types that we support, we went in and supported all the ones that are in Consolidated CDA Release 2.1, except for that one I mentioned, the unstructured document. All these document types use the US Realm header profile as a base profile, so they inherit all those constraints I already mentioned. So the subject for a care plan still needs to be a US Core patient, and we just pick that up. We don't have to redo that again. It's inherited from that base profile. Each of these document types basically adds additional constraints. The primary constraints that are added are the composition type, which says the LOINC code or value set of LOINC codes for this particular document type. And we also define the legal sections that are allowed in each of these document types. And I'll walk through a couple of these later. So I'll start with the CCD, or Continuity of Care document. This one is probably the most common document type exchanged in the US, just because the original version of Meaning for Use cited only the CCD document type. So that's what a lot of EHRs implemented, and even though later versions of Meaning for Use allowed other document types, you still see this as probably the most common one that's shared. Therefore, we expect it to be highly prevalent in C-CDA on FHIR. It is a summary document type. It's intended for transcript of care scenarios, and I like to think of it as being sort of an EHR data dump. It's one of these document types that often when an implementer says I need to, or they're told they need to implement a CCD, they just dump everything that they know about the patient into it, and you end up with these 60-page summary documents. And when you think that many of these are supposed to be human readable as well, or all of them should be, no one would actually want to read a 60-page summary. In fact, that's a lot of feedback that you get from clinicians is they hate the CCD document type because it's really unreadable. It's too much information, or it's the wrong information, or maybe they just want to see their latest lab results, not every lab result this person has ever had in their entire history of care at this hospital. So it's kind of a scary document type. Personally, I hope that over time these will go away, because when you get to FHIR, you can just query for the information you want. You don't have to send this big data dump of everything you know about the patient anymore. So the Ccd header, basically, as I said before, it's pretty light. It constrains the document type code or composition type to this value from LOINC, that 34133-9, which is the LOINC code for summarization of episode note. And it also requires that we have a service event present with start and end dates. And there's a fixed code here for FHIR, which is which is basically for provision of care over time. And basically all this is saying is this is documenting an event of caring for a patient from this start date to this end date. We then go in and require or create a catalog of sections that we can use in this document type. There are basically 6 required sections: allergies, meds, problems, results, vital signs, and social history. And then the rest of these sections are optional, and you may as an implementer choose to add them. Often what you see are just these 6 sections and nothing else, or if there is anything else, it'll probably be like immunizations present. Some of the key profiles that are used in CCD sections are all these US Core ones that are listed here. Again, this is a subset of what's available in US Core. We don't use all of US Core, but we use most of it in various document types. CCD uses, again, about this many here. But we've also got references to other unprofiled resources. One thing that was interesting is US Core didn't create a profile for Encounter, for instance, because it wasn't in their scope. It wasn't in the common clinical data set. So for that case, we just point to the raw Encounter resource and say, here you go. Please, try to use the same codes that you used in the consolidated CDA, HL7 version 3 based spec. Now the US Core project is sort of restarting and tackling some of these other issues. So we will see, for instance, a US Core Encounter in the near future, but it's just realize it's not quite there right now. All right, so enough talk. Let me go ahead and drop out of presentation mode and show the specification itself. So here, it's a little bigger. So this is the C-CDA on FHIR spec, and it starts off with just some background information on CDA and consolidated CDA and why we're creating this guide and what its scope is. Lists the key authors and some implementation notes, such as difference, the fact that there are differences between US core and C-CDA, and some approaches to things like negative values and nulls are different between CDA and how they're done in FHIR. So some of these things are listed. It's on this front page as a warning to the user, basically. Then we go into the Profiles tab. And on here, this is where we actually have all the profiles for CCD on FHIR. So I'm going to start with the US ROM header and bring this one up. And hopefully on this page, this will be a little more readable, so we can kind of scroll. So this shows that this is a composition resource. We, again, point to US core patient or the unprofiled FHIR group resource if you want to have multiple patients, which is legal. Date we require things, author can be any of these types. It can be a US core practitioner, it can be practitioner role. There are patient author documents. We allow a US core patient. You can also have device author documents. It's perfectly possible that a device could be generating some of these documents. And then if we scroll down here, again, we've got some things like a tester. This is, in CDA, we would call this the legal authenticator, the person signing the document. We require that to be a US core practitioner for the legal authenticator. But you may have additional people signing these documents, like maybe residents and such, who could sign with a professional code. And again, you can have patient author documents. We do allow that as well. We've then got some of those key extensions that I mentioned, and again, they typically just reference US core profiles. And that's about it for the header. If we go to one of these more specific document types, and let me just use the consultation note as an example. Let's bring this up. Here we can scroll down and see that this one has a composition type that is fixed to a value set in this case. And we can open up this value set and see the different types of consult notes that are allowed. And these are all link codes. So it's a value set. Any of those are appropriate. Often you use the most generic one, which is just for consult note. We then require an encounter to be documented in a consult note. In this case, again, since US core had no encounter, this is just the unprofiled encounter resource, but you can still use everything that's available on there. Then we go down into the various sections. So we require in this one an allergies and tolerance section, history of present illness, and quite a few others. So there's a bunch of required sections in here. And as you scroll down towards the bottom, we get to some optional sections like functional status, family history, and such. And again, wherever US core created profiles, we use them, and wherever they did not, like family member history, we just point to the base unprofiled resource. Okay, so I've talked about US core quite a bit here. So why don't we go and take a look at that now? So if I were to click on one of these links here, these are the things that were broken in the ballot version, I can click on this and go to the US core patient profile. And I can scroll down here, and as I discussed, click on this, and you can see the things that must be supported in the US. But if you click on the snapshot table, you can see everything that is legal in the patient resource itself. So usually we don't prohibit anything, except for some reason, US core said that we don't want information about a patient's service animals recorded, which is kind of strange, but that's what we did. You can sort of see that in the differential table that we've actually prohibited. We made a cardinality of 0 to 0 for animal here. Again, US core has quite a bit of profiles in it. You can go to US core home and scroll down and see all the various profiles right here. Click through any of these that you want. And like if you want to see the US core procedure profile, you can click on that and scroll down and see what's required for procedures. Again, and what's available in the whole procedure resource itself, if you wish. So next, one thing we've also done, this CCD on FHIR went through ballot in February. we're working on final publication, but in the meantime, we had other use cases for things like a pharmacist care plan. So C-CDA on FHIR has a care plan document type, but for the pharmacist use case, they wanted a little bit more specificity about medication dispense, medication requests, or prescriptions and such. So we actually went ahead and started creating a basically a care plan or a pharmacist care plan profile built on top of the C-CDA on FHIR care plan. So you can click in here and see what a pharmacist care plan looks like. And in here you can see that this is based on the US Realm header, has all the same sections as the regular care plan, but with some additional specificity, such as we actually created what we call intervention lists, and we did profiles on, if you go inside one of these here, see that we did profiles for medication requests, or we pointed to the US Core medication request profile, and things like referrals or procedure requests and such. As part of this project also, and this is one that was sponsored by the Office of National Coordinator, ONC, we've actually created dual implementation guides, one based on CDA and one based on FHIR. And then we were charged with creating transforms between the two, so that any implementers could actually pick either the older CDA spec or the new FHIR spec, but a receiver could convert between either of those formats. And I'd like to quickly demonstrate that for you. I think I've got a few more minutes left. So this here is an example of a CDA-based pharmacist care plan. And if folks have seen CDA before, this will look very familiar. It's ugly old XML. You can sort of scroll down and see we've got the title, the effective date. You can see patient information present, such as their IDs, their address, name, and such. Then when I actually run this through our converter, we end up with a FHIR document bundle. And at the top here, we've got the composition resource, all the text that was represented in the Cda Header. And then we can scroll down, we've got the same link code, that care plan document type code. We've got references, in this case, to the subject, or the patient. And if I were to just go down there, let's see. We can actually take a look at the patient resource and see that all that information that was present in the record target, the CDA, is represented here. So we've got their identifiers, their name information, their telephone and email addresses all present. So these got pulled over from CDA. Likewise, where the CDA had some coded information such as, let me see here, some observations. In this case, we've got observations that are, this one I believe is for constipation, right? Yep, so we've got a SNOMED code for constipation. This is basically a C-CDA problem observation. And when we take this, let me just copy that code so I can get right to the same spot, and view the converted document, we can see that this problem observation got converted into a FHIR condition resource. And so all the coding is still present. It's just been changed into FHIR syntax, where we had voids in CDA to represent the SNOMED code system. Now we've got URIs, so this is much more readable. And also, in CDA, things like the context, who the patient is, who the author is just assumed. It's sort of inherited by the hierarchy of the XML. In FHIR, you don't do that because you want these resources to be safely processable when you take them outside of the document. So we actually put in references to, for instance, the patient resource that's also in this bundle, and the practitioner that authored this document. So all that is now present. And that's useful when you want to take these and, for instance, break them apart, which I'm going to demonstrate doing right now. So this FHIR bundle at this point is of type document. So this is a FHIR document. You were in my tutorial yesterday, you know what that is. But there are many types of bundles. One of them that FHIR uses is also called a transaction bundle. So I'm going to run this little converter that takes a document bundle and converts it into a transaction. And it does that by changing this name to transaction. And adding this little request method at the bottom that basically for each resource it'll say, post this to the composition endpoint. Okay? So now I can take this whole thing here and copy it. And I'm going to post it to the Happy server. And assuming Happy is up, I should get a result. Yep, okay, I got a 200 okay. I'm just going to talk loud here now because I only got a couple minutes left. And what I see here is I've got created a bunch of resources for me, like a patient resource and such. Basically, every resource in this bundle is now posted separately to the Happy server. And once that's done, it's actually broken apart now, and you can access these independently. So I can go to a tool like FHIR and click on the patient viewer, select a patient, and I'm going to paste in that ID from the document that I just did and load it. All right? And I can click on this resource references graph, and now all this information that was previously present in a HL7 version 3 based CDA document is now all accessible as discrete FHIR resources. So I can go in here, I can take a look at their functional status observation, I can scroll in here, let me make this a little bit bigger, and look at, ooh, that's too big. Take a look at their procedure requests or their conditions, such as opioid abuse. And all these are now available as discrete data, and they are safely linked back to the patient resource and the original composition. So this is a very powerful way to, for instance, take existing legacy data out of EHRs and populate FHIR servers and start using them much more easily today than you could by processing CDA documents. All right. So I think that's about it. Let's go ahead and just wrap up here. So the timeline for CCDA on FHIR, by the way, its first ballot was in September 2016. That was a 4-comment ballot. In January of this year, we actually went to ballot as an STU. Took us a while to wrap all that up and get through IG publishing issues. But as I said, the final publication is imminent at this point. We've asked for withdrawal of all negatives and are now in the final mechanism for publishing. So if anybody's interested in the resources, this is a good one to take a picture of. So you can see the CCDA on FHIR spec where it is in the build, US core as well. Those transforms I mentioned are open source. Just be aware though they're only they cover the pharmacist care plan fully. They don't necessarily cover other document types like CCD and such, but they are extendable and open source. We hope people will contribute to them in the future as well. And then myself, I'm available at that email address, and welcome your questions in the 30 seconds that we have left. Yes?
So what's your plan for handling unstructured documents?
Well, we've had some discussions in the Structured Documents Working Group about that. It looks like we're leaning towards doing another profile at a later point on composition. After speaking with Graham Grieve, he mentioned how they did it in Australia, which is, even in CDA, they just embed the PDFs in a section. In CDA, there actually is a specific element for what we call a non-XML body for pointing to a PDF. We discussed whether we should add something similar to that to composition and kind of decided, no, maybe we're going to take Graham's approach. But we haven't actually done that profile yet. But in the meantime, you can use document reference that's been available in the core FHIR spec basically from the start of the get-go. And it has all the, nearly all the same metadata as composition, and is designed to point to another document like a PDF. Yes?
Is it possible to convert from the C-CDA to CDA?
From FHIR back. Yes, it is possible. In fact, let me just quickly show that. So if I've got a FHIR document here like this, I can convert this back into a CDA as well. Now, there is the potential for some loss, mainly just in areas where FHIR is a lot broader than CDA.
So it might not be possible to represent all information, but if you restrict yourself in your use of FHIR to the things that are available in CDA, you can get pretty good coverage there.
Very good.
Yeah, I mean, we haven't, covered, like I said, all documents or all of CDA, just the pharmacist care plan is. But in theory, you could. Right, I think we're over on time now, so if folks want to talk to me at lunch or at the next break or whatever, I'll be around. Thank you.